All right, so in this video in section 5.6, we're going to be doing exponential functions and logarithms, and you're looking at about maybe 10 videos of different word problems trying to use some of the techniques from earlier in this chapter to rewrite and isolate our exponential or logarithmic equation that has the side that has at least the x on it, so then we can eventually solve for x. So here are some general equations or steps to use for solving exponential functions. Isolate the exponential expression on one side of the equation. So do some inverse operations. Get the exponential expression like e to the 5x, or maybe it's 2 to the x plus 1. Get it on one side of the problem by itself. Now we take the logarithm of each side. Again, try to take the log base, whatever the base that is being raised to the next exponent, to the letter exponent. We use the same base there. It makes life easier. Apply either the inverse property or the power rule. That's just rewriting some things. And then solve for the variable. So as we go through, let's do some examples. The world population in billions during year X can be modeled by the following equation. They asked us to solve it, and they asked us to do it symbolically. So we're just going to solve it just by doing just algebra is what that is. And that's typically the faster way to do it compared to doing graphically. So with that in mind, as I rewrite the problem, let's go through our inverse operations. Our goal is to get that x there that I just wrote down by itself on one side of the problem. So now we need to isolate it. So that means go ahead and divide off the 7. And so we're going to go ahead and divide by 7, and we're going to have 1.01 raised to the x minus 2011, and then that's equal to 8/7. Now we don't want to divide that out, because if we divide that out, it's a repeating decimal, so it's easier to leave that one as a fraction. Now we're ready to take the logarithm of both sides, and you get a couple options here. You can take the ln of both sides. I'm going to do log base 101. Log base 101, and the reason why I'm doing that is so that it can cancel the 101 base that we have there. Now we got to do the same thing to the other side by the properties of equality, and that's 8/7 as a fraction. And then now the log base 101 cancels the 101, and I'm left with x minus 2011 equals log base 1.01 of 8/7. And then now we would add the 2011 over to the other side. And again, it goes on as the end is a constant. So x is equal to log of 1.01, base 101 of 8/7. And then that's all being added to 2011. Now we're ready for the calculator. And remember, in previous lesson, we learned to use the log base button. Is what we used in the previous lesson, so we should be able to find that quickly. If you forgot, that's okay. I'll help you figure it out real quickly here. So as I clear my screen, we can type that in one fell swoop. We just got to be careful. So we go alpha window, and option number 5 is log base. So we're going to go ahead and put that on our screen. Go ahead and type in our 1.01 for our base. And then now inside there, we can put a fraction, alpha y equals. And then I'm going to put 8/7. Again, that's the most accurate way to represent it. So let's leave it like that. Don't take it and stuff. And then now do plus 2011. And then I'm going to hit enter. And that tells me that approximately 2024.42. Now that's basically telling us, if we read the problem, it says, when would the world population reach 8 billion? So basically what that's saying is the year 2024, and it's almost a half a year into that year. So you're looking at like 0.42 of a year. Again, we can't just say it's 4 months in, but we would have to do something different. But you know, we're at least saying part way into the year, so somewhere maybe around March to April, somewhere in that time frame, or maybe May, somewhere in there. You figure June is the 6th month, so that's 0.5. So it could be somewhere in that May to, or May time frame is when this occurs.